Okay, so in this video we're going to revise how to sketch graphs of circular functions, sine and cosine at least. We can do tangents in another video. These two things are periodic functions, which means they repeat themselves over and over and over. Now the length of time it takes to repeat is called the period, and that is given by 2 pi over n, where n is dilation factor in our graph. Dilation from the y-axis, well, 1 over the dilation at least. Okay, so if I increase the value of n, I decrease the period. And that makes sense from transformations, because if that is my shape of a graph there, I know that if I put n equals 2, it means I'm squishing the graph in by a factor of a half, which therefore decreases the period. So that should make some sense. They have the general equations here. The value of a at the front, that gives us the amplitude of our graphs. Our amplitude is given by the absolute value of a. Now it's called the absolute value because we don't want negatives. Sometimes you might have -3 at the front, but that just means that the amplitude is +3. This d, as always, gives you a vertical translation. If a is negative, it flips it upside down. And if you solve nx plus c equal to 0, you'll find your horizontal translation. Cosine graphs always have this general shape. They go between -1 and 1 if the a value is 1. If whatever a value is, that's how low it goes and how high it goes. So you might end up with -2 to 2, -3 to 3. This is, of course, assuming there's no vertical translation. It always goes from the middle line, whatever d value is your middle line, it goes up amplitude, down amplitude. And here's your sine graphs. So sine graphs tend to start, or not tend to, they do start on the origin where there's no translations. And we'll look in a minute how to deal with it when we have translations. And then we apply transformations to these things to find the different variants. So let's sketch each of the following. This first one has no translation, so it's a bit easier. So first of all, I need to find my endpoints. So endpoints, x equals 0. So you get y equals 2 sine of 0, which your exact values mean you have 0. So one endpoint there is at 0, 0. And it's closed circle because it's included. The other endpoint occurs at x equals 2 pi. So we have y equals 2 sine of 3 times 2 pi is 6 pi. Now in our unit circle, that would be 1, 2, 3 back there, 3 full revolutions, which gives you 0 for sine as well. So 2 pi is 0. So what have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. We'll do that. All right. That can be 2 pi 0 there. We have 0, 0 there. Next, we want to find our, we don't need to find our y-intercept, it's already there, so we're going to find our x-intercepts now. Now, there's no vertical or horizontal translations here, so it's all going to be in terms of sine. We know sine is 0 there and 0 there. So at 0, pi, 2 pi, 3 pi, and so forth is all going to be your solutions. But then we have a dilation of 1/3. So we're going to divide all of our solutions by 3. Excuse me. So your x-intercepts are just going to be 3x, which is what is inside here, equals 0, pi, 2 pi. We're going to keep going up and so forth all the way until you get to the end of our domain and divide by 3. All right, go to look at the solving circular functions video to help you work these things out all the way out. We know the period. I've looked at the period at the start. The period is 2 pi over 3 because there's a 3 there. It's 2 pi divided by that 3. And that means 1/3 of this. So there are 3 periods in that, which is why I count out the 9 early. So there's 1, there's 2, there's 3. And I know the graph between here and there must go up, down, up is what I've got to get to. All right. With a sine graph, there's no translations. The halfway point there is an intercept. So that's 0. This will be a 2 pi and 3 here. That's one full period. Halfway between is pi and 3. There's 2 pi and 3 there. This will be 4 pi and 3 here. We add one more period, so halfway between is going to be our 3 pi and 3. And then 5 pi and 3 will be there. And then we're going to sketch it from there. And it doesn't matter how high we go, as long as we label it as 2 units. That's the main thing. So let's not overstretch ourselves by going too high. That one. That one there. And then there, little kinks that would fix up with an eraser. And at the end, you would label all your intercepts. Now, they typically in exams ask for the coordinates, which is why I'm running the coordinates now. If it just said label intercepts, you could just label 5 pi and 3 as a value rather than run the coordinate. But that is how you sketch a graph. I should put a scale there so that indicates that I know it goes up to -2 and down to, well, up to 2 down to -2. Next example, we're going to look at y equals negative cosine 2x plus 1. This one does have a vertical translation. This time we also have a different domain from negative pi to pi. But I've chosen this one here because although it does have a vertical translation of 1, which means instead of being that's kind of our middle line there, the whole thing's been moved up 1. So we have a new middle line about there somewhere. And we notice our amplitude is 1 and matches it. So what that's going to mean is if I have there's going to be 1 there, there can be 2 there, and 0 down there. 1 is my middle line, that plus 1, and it's going to go up 1, down 1, up 1, down 1. So it means it's not going to go below the x-axis at all, which is nice. Now the period is 2 pi over this 2, which is pi, which means between 0 and pi, here and we can call it here, that's going to be 1 full period. Pi's going to go up there. And between 0 and negative pi, it's another full period from there down to there. It'll be another full period. So we have 2 full periods happening here. It's now a matter of sketching them. But to sketch them, I need to know where they're going to start and end. So endpoint, you're going to have negative cosine of 2 pi plus 1. Now cosine of 2 pi is 1. You have negative 1 plus 1 is 0. So you're going to have it starting there, oh sorry, up this end. But it's also going to finish there as well because you have, whoops, sorry. Like that, cosine of negative 2 pi just means they're going back 2 pi around. To start again, we know cosine is 1 there as well, so you're going to end up with 0. There we go. The y-intercept, we know the y-intercept, continue going with that. Y-intercept, we have x equals 0. So that gives you negative, y equals negative cosine of 0 plus 1. Cosine of 0 is 1, and we end up with 0 once more. Lots of zeros happening here. So our y-intercept is going to be at 0, 0. The last thing to recognise before we draw this thing is that we have a negative cosine graph, which means instead of the graph starting up here, it means it's going to start down here and go up. All right, so let's put all this together, sketch our graph. So what I'm going to do, I'm going to put this line in here, and I'm going to treat this line here as my new x-axis. I've moved the whole graph up 1. That's what the plus 1 means. I'm going to move the x-axis up there. I'm going to get rid of it at the end. You can draw it on an exam or something with really light pencil all the way across. You can easily erase it at the end. Now I'm going to draw this graph as though, there's my y-axis there. It would normally start there and go down, pretending that this is my x-intercept, my axis I should say, because the negative is going to start here. It's going to go up and come back down. Now we're told there's 1 full period. It's going to go up there and come back down there. Let's see how it works. We go up through there and back down into there. So up and through and then down with some kind of curve back towards like that. And then I'm going to do the same thing from the other section as well. Up through there, down through there, something like that. And then to finish it, I'm going to remove the axis, the fake axis, I should say. And I've labeled them intercepts. I haven't labeled them as coordinates, but if the question doesn't state it, you can just leave it as pi, but it's a good habit to write coordinates because I'm sure you'll be asked at some stage. Last couple. These ones here, we're going to have the endpoint again. We have a period. The period, sorry, is 2 pi over 3, because there's 3 there again. So we're going to have starting at 0, ending at 4 pi and 3. That means there's 2 periods from there to there, because 2 pi and 3 times by 2 will give you 4 pi and 3. So there's 2 full periods. And we're going to find our endpoints. So at x equals 0, you have y equals √2 sine of 0 plus 1, which is just 1. So it's going to start there at 1. And we're going to have x is, the end is 4 pi and 3. It's 2 full periods array, so it should end up at 1 as well. So y equals √2 sine. Now 4 pi and 3 times by 3 cancels out, becomes 4 pi. Now sine of 4 pi, the unit circle is 1, 2, there, which is 0 as well. So we're going to have 1, 2, there we go. We're going to end up with 4 pi on 3, comma 1 is going to go there. Now I know I've got 2 periods, so with the sine graph, it's going to go up and down and up in that time frame. It's got to cross back at the same height halfway. And then how far you go up is going to be determined by amplitude. Now amplitude here, amplitude is √2, which is approximately 1.41, which means I'm going to start at 1 and I have to go up 1 unit and a bit more. All right, and it's going to be exactly halfway between those two. So it's going to be something like that. And then going down 1 and a bit more, it's going to be something the lines of about there somewhere, because every grid is 1. So we're going to go up, down, keep coming down, go through there, back up to there. And I'm going to continue on and do the same thing for the second half. Now in this case, we've got to find our x-intercept still, which we'll get in a second. To find a detailed way of how to solve your x-intercept, you'll need to go and look at the solving circular functions video I've done already. I'm just going to quickly go through it now to finish it off. And we get 0 there. So to solve this, remember you have y equals 0. You have 0 equals all this, which means sine of 3x must be -1 and √2. We know that. That gives me 3x, and -1 and √2 we know has a pi and 4. It's in the 3rd and 4th quadrants though, so it's going to be pi plus pi and 4, which is 5 pi and 4, and 2 pi minus pi and 4, which is 7 pi and 4. And then we divide by 3 to get 5 pi and 12 and 7 pi and 12. Now that is going to be the first 2 periods. There's 5 pi and 12 there, 7 pi and 12 in there. To find the other ones, I just add a whole period. So what I'm going to do is I'm going to add 2 pi, a standard period of a graph, to 5 pi and 4. Now 2 pi is 8 pi over 4, so I'm going to add 1 period to that to give you 13 pi and 4. And add 1 to this one gives you 15 pi and 4. So now when I divide by the 3, you're going to get 13 pi and 12, and a 15 pi and 12. 13 pi and 12 goes here, and the 15 pi and 12 goes here, but that cancels down because it's a common factor to 5 pi over 4. All right, final one. This one has got a horizontal translation, which is why I've left it till the end. They're always the most tricky, and also you'll find this time I've made sure that the sorry, made sure that the period comes out to a nice whole number. So we have endpoints and period. Now the period in this case is 2 pi over the coefficient of x, which is pi. So the period is 2. So between 0 and 2, there's going to be 1 period, and between 0 and -1, there's going to be half a period. So we've got 1.5 periods happening here. All right. So let's find some endpoints. The endpoint of the first one, you get y equals 3 cosine pi of -1 plus 1 plus a 1.5. Now, -1 plus 1 is 0. Cosine of 0 is 1. 3 plus 1.5 is 4.5. Okay. The other endpoint is when you have 2. 2 plus 1 there. Yeah, 3 pi. Cosine of 3 pi here is -1. Oops, that should not be 4.5 there. Sorry, that should be a minus up there. Don't know why I wrote plus. That's minus 1.5. So you should get positive 1.5 there. Sorry. This one is going to be -4.5 because 3 times -1 is -3. Take away 1.5 is -4.5. So you have -1, 1.5, and 2 -4.5 endpoints. Your y-intercept, you have x is 0, so you have y equals 3 cosine pi of 0 plus 1, take 1.5. This is cosine of pi, which is -1, so you're going to end up with -4.5 as well. All right, so I'm going to call each one of these 1.5s. So I'm going to go and have a full cycle between there and there. That's what I'm told by this thing here. I'm going to end up down there. I'm going to finish at 2, -4.5. I need to come back and go through 0, -4.5. And then I'm going to finish at another half a period. So every period is 4 of these blocks, 1, 2, 3, 4. So half a period is there. So I'm going to go up to 1.5. I'm going to stop there, -1. All right, so I've got to find some intercepts as well. So I know between this one and this one here, I have a full period, and I know that I've got to go. So I've got -1.5 here. We talked about this in the axes before. I've got -1.5 there. Becomes my axes there. Sorry. And I'm going to now sketch up and down. That's a terrible, terrible effort. Let's try that again. So I want to try to get up through there and come rounded over the top of that one, and then come back down through there to the bottom, and that's much better. And do the same thing. It's got to go through that little halfway point there because these things are symmetrical, nice and smooth. Something like that. So now I've drawn that because I moved my axis down. I pretended this thing here was my -1.5. I pretended that was my x-axis, and now I've sketched the graph. Final step, of course, is to find those intercepts. I should also label some scale on the graph here. Last thing, x-intercepts. So x-intercepts, we know y equals 0. So you have 0 equals 3 cosine pi x plus 1 minus 1.5. We add 1.5 across and divide by 3, and we get a half. Okay, to solve this now, remember cosine of what is a half? Well, that's going to be pi and 3 in the first quadrant, and in our second quadrant there, our fourth quadrant there. So we're going to have pi bracket x plus 1. You get pi and 3 in your first quadrant, and you get 5 pi and 3 in your final quadrant. Divide it by pi and subtract by 1, and you'll end up with -2/3 and 2/3. So the negative 2/3 is down here, which is interesting because we solved for the first two solutions. You'd think it would have been those two. But what we've got is a translation to the left of 1. We have a graph that's moved left 1, so we would have assumed it should have been the first one there, but it was not. Okay, we've got a half of a period left. Remember, sorry, not that one there. This would normally have been our starting point because we've moved it left 1. That's half of the period. So this whole section would normally have been over here. We've moved it across half a period, and that's why we start down the bottom instead, even though it's not a negative cosine graph. So this one down here is 0 as the y of a, negative 2/3. This one here is 2/3, comma 0. And this one here is going to be this one plus a period. Now that one plus the period, if I have negative 2/3 plus 1 period, which is 2 pi, that gives you 4/3. You have 4/3, 0 there. Sketching circular functions is not the easiest topic that we do, but hopefully that helps you remember how to do it and give you some different ways to think about it as you go through.